about right triangles this unit, so today we'll start by reviewing Pythagorean theorem. Pythagorean theorem is used to find the missing sides of a right triangle. A and B are the legs, and C is the hypotenuse. Now, the hypotenuse is always bigger than the legs. So the hypotenuse is the longest side, and it's directly across from this right angle. So here's your Pythagorean theorem. C squared, the hypotenuse, equals A squared plus B squared. Here are some common Pythagorean triples. That means two legs and a hypotenuse that make a right triangle that satisfy A squared plus B squared equals C squared, just for your reference. You don't have to know these. So let's do a couple of examples. On this one, X is the C, so hypotenuse is what we're looking for. A and B can be interchangeable. It doesn't matter which side you call A and which one you call B. So A squared plus B squared equals C squared. 8 squared plus 13 squared equals C squared. I don't want to know C squared. I want to know just C. So the way you get rid of the squared and get just C is to take the square root of it. But what you do to one side, you have to do to the other. So the square root of 8 squared plus 13 squared is rounded to about 15.26. So if you'll skip to number 3, the difference here is that my X, the missing piece is one of the sides. I'm going to call it A. I know the hypotenuse. So if I do A squared plus B squared equals C squared, I have A squared plus 7 squared equals 9 squared. So to solve for A squared, I have to subtract the 7 squared from both sides, and then to get just A, I need the square root of both sides. So A squared, this time it's going to be a weird number. It's like 5.6 repeating. Look at number 5. This is an isosceles triangle because these two sides are marked congruent. On an isosceles triangle, when you drop the altitude at a right angle to the other side, it bisects it. So that makes this 11 and this 11. So if I'm looking for X, I've got this right triangle here where this is C. So when I know C, hypotenuse, the biggest, that's when I subtract under the radical shortcut here to get the missing side. So A or B or whatever you want to call it, it doesn't matter if you call it A or B, is 21.33. Now, it has to be smaller than the hypotenuse. So if you get a bigger number than the hypotenuse, you did something wrong. Let's look at this one. Well, this is a trapezoid. Is there a way that I could make a right triangle? Well, I could do this, but I don't have enough information to solve for X. So let's try something else. Let's try dropping a parallel line. If it's parallel, it's at a right angle. I'm making a rectangle here. If it's a rectangle, then this side is 5, just like this one. This is X, just like this. So how long is this? 18 minus 5. This is 13. So now I'm using Pythagorean theorem on this to find one of the legs. I know C, the hypotenuse. So I'm going to do a subtraction. And then I'm going to get about that X is about 9.33. All right, on this one, I want to know X. Well, it's not the side of a right triangle, but this big triangle is split into two smaller right triangles. So on this one, I could find this piece by going square root of 14 minus square root of 12. Then on this right triangle, I could find this piece by going square root of 29 squared minus 12 squared. Oops, I left that off. So what I get for this is 7.21. That's this piece. What I get for this is 26.40. And then I need to add those together to get my answer, to get x. X is 33.61. So that one had to be done in a couple of pieces. All right, word problems. So when you do these, you pretend we're in a perfect world. And in a perfect world, a house makes a right angle with the ground. So we have a ladder that's 16 feet high, leaned up against my house. The base of the ladder is 5 feet from the house. How high up the house does the ladder reach? So this is going to be square root of 16 squared minus 5 squared because I know the hypotenuse. And this one is going to get me 15.2 feet. Now the next one, Asher's building a rectangular deck. So I have a rectangle, which is 4 right angles, correct? The dimensions are 10 by 23, and we want to know the length of the diagonal. I have no idea why he wants to know the length of the diagonal, but he's just a curious guy. So put this in your calculator, and you're going to get that the diagonal is approximately 25 feet. It's the hypotenuse, so it should be the longest, longer than both sides, and it is. I'm going to skip down to the converse. The converse of the Pythagorean theorem says that if you have 3 sides of a triangle and a squared plus b squared equals c squared, then you know it's a right triangle. So are these right triangles? If they are, 7 squared plus 8 squared would equal square root of 113 squared. Now, I know we haven't dealt with this a lot, but when you square a square root, it just drops the square root and gets 113. So let me pull out my calculator. And 7 squared plus 8 squared equals 113. So, yes, this is a right triangle. Let's check this one. Is 14 squared plus 22 squared equals 26 squared? Remember that the hypotenuse is the longest. 26 squared is 676. And $680. No, not a right triangle. Then we have this Pythagorean inequalities theorem. It says that for any triangle where c is the length of the following side, of the longest side, the following is true. If c squared, now we already know that if c squared equals a squared plus b squared, that's Pythagorean theorem. So that makes a right triangle. So the new information we have is that if c squared is less than a squared plus b squared, then the triangle is acute. And if c squared is greater than a squared plus b squared, then the triangle is obtuse. So kind of a way you can classify without knowing the angles. Now, in order to not avoid confusion, we need to do the c squared first. Keep it on the left. So I did the c squared. If it's equal, it's right. If it's less than, it's acute. Makes sense, right? If it's greater than, it's obtuse. So first we need to decide, can these 3 side lengths form a triangle? Now, not sure we remember this, but the sum of the 2 smaller sides must be greater than the third side. So smaller. If you add the 2 smaller sides together, it must be greater than the third. So yes, it's a triangle. So is it obtuse, acute, or right? C squared is 81. A squared plus B squared, that's 9 plus 49. So that is 58. C squared's greater, so it's an obtuse triangle. Then we check this one. We're going to check one more here. 4 squared plus 11 squared, 16 squared. 16 squared is, I think it's 256, if I remember right. This is 16 plus 121, which is 137. Greater, it's obtuse again. Actually, wait a minute. I forgot. I got distracted. I forgot to check and see. That's what I was going to do and got distracted. 4 squared plus 11 squared. Now I already forgot what I said that was. No. Just give my brain a moment. 4 plus 11 is 15. That's not greater than this, so it's not a triangle. We'll stop there.